Yeah. So write this question. So this question is according to the graph method, whether it is possible or not, we will try to see. Okay. The following graph do not exist in practice. Okay. The following graph do not exist in practice in the sense. Now you see the first graph is VT graph. Second graph is XT graph. Third graph is what is that here? AT graph. Yes or no? This is VT and this is XT and this is a AT. Yes or no? Acceleration time graph. Now we need to analyze this graph and we need to write its answer. Yes or no? So how and all we'll try to see. Listen. Now if I just check the point here, here let's see here. Can you see the point here? Yes or no? It is let's say P pointer. It is let's say Q pointer. A body cannot have two different velocity at a time. Is it possible like that? At a time the two velocities possible? No, it's not possible. But this graph is shown in this manner, so this is not possible. This graph is completely not possible. Right? Let's see the second one. Second one is looks like this, but try to see now x1 and x2. At any time, for example, here there is a time, let's say P point, here is a Q point. Yes or no? At a time, body can be at the two different places, two different position. Right now you are locating in a lab, right? The same way you will be in the same time. Will you be there on there in your class? No, it's not there. So for reality, you cannot be there. Clear? So this is also not possible. What about acceleration? Will it be possible acceleration? Two different linear acceleration is possible? No. Two different rotatory and other acceleration can be possible, but linear acceleration is not possible. Okay. So what is it meaning here? So here simply, so at a time two accelerations are not possible for a body. Means same time two different acceleration will not be possible. So basically these graphs are not possible in a motion in a straight line. Clear? Yes or no? No done. So what can I write here? Body cannot possess possesses the two different displacements velocities and accelerations in a same time or at a same time. I can write at a same time. Right? Is it clear? No doubt. Where is single kid? कहाँ पे है? Where is she? She is absent. What's your name, buddy? Pranika, right? Pranita. What's your name, buddy? Your twin sister? Huh? Nivedita. You both are twins? Siblings? Maybe in Purva Janma both are twin sisters. Is it possible like that? Maybe. No. Then, buddy, shall we move on? The new girl, are you able to understand, right? What's your name? Netra. That's it. Very good. Chalo. Shall I move on, right? Geetika, still writing? Ah, right. So I am moving on. You can write. Okay? Finish, right? Geetika, local brand I know yesterday you had, but little bit faster. Slowly, क्या है ये? हाँ? Something is there. Done. This one. अच्छा no. चलो write this one. Second question. This is speed versus t graph, and this is a distance versus t graph. Okay. Is this graph possible? Is this graph possible? No. Because speed is a positive quantity, it is a scalar quantity. What is this one here? Scalar. I told you speed is a scalar. Distance is also what is it? Scalar. Right? Am I correct? Now I will say that a speed is a magnitude of whom? Magnitude of velocity. Yes or no? So magnitude is always what is it here? It can be 0 or it can be positive value. Yes or no? But it cannot be negative. But you see the graph is actually pointed downward direction. Is it possible? Velocity can be possible. Negative, 0, positive also possible. But speed is a scalar quantity. It can be 0 or else it can be positive. But here it is what is a speed is a magnitude of velocity. So it cannot be negative. Am I correct? It cannot be negative. Whereas now this one you tell me, distance is scalar quantity. Distance is what is it here? Distance is magnitude of whom ray? Magnitude of displacement. So it can be also, can be, what is this ray? It can be also 0 or it can be also positive but no negative. Yes or no? So same dialogue you can write here also. What is it? It cannot be negative and these graphs are not possible. Okay? Not possible, then it is very happy. Chalo. Is it done? So fourth hour is also 2 yours only. Am I correct? Done? Any difficulty? No. Shall I move on? No talking, buddy, during the class. No talk. Is it finished? So next, you can actually write next one here. This one. Graph number 3. This is xt graph. This is vt graph. This is at graph. So now tell me, what is the answer? Going. Chalo. What is this, buddy? Now tell me. I need an answer for this one. So clearly, these graphs are there. XT is there, VT is there, AT will be there, right? Now, any body, now the time was constant, but it is covering what is it here? Distance. Is it possible like that? Yes or no? Time will not stop. You are changing. Now I am moving from there to here. Obviously, time will be there, right? And time never be constant. So now what happens here? The body is actually now at t time na it should be at one position, but it is what is it doing here? This graph is indicating a like this. Yes or no? It is moving. Means the value of x is keep on increasing. Yes or no? Is it possible? No. Similarly, Vt is also there. Now you see here time was same only. Here time is t1 and now velocity is also keep on increasing. Is it possible? The same time you cannot do it. So similarly here also the time is here t1 and the graph is keep on increasing like this. So here in this situation time cannot be constant. Constant if particle is moving or rest also. In a rest also time cannot be constant. Time is keep on moving only. Yes or no? It's always a variable. So this graph is also not possible. This graph is also not possible. Yes or no? Then shall we move on? Not possible means it is important for you. Okay, just you have to learn it. Shall I move on? What about this one? Write down this question. The displacement of particle as a function of time as shown in figure. The figure is there like this. Very good figure. Okay. Now we need to start answering. Everyone is maintaining notes, right? Writing in classwork only, I guess. Now, shall we solve this question? So now let's see now what is happening in here. Now the displacement was not at all linear. It is actually rapidly increasing. As the time increases, it is rapidly increasing. After that, what is happening, buddy? You see, like this, like this, like this, like this. It became completely, what is it here? Parallel to time. Yes or no? Parallel to time or not? Am I correct? Now it is started from 10, rapidly grown. After that, when it reached the 20, it's completely become parallel to time. Yes or no? Now we know already the slope of VT graph. Is it VT graph? Is it VT graph? XT graph. Very good. Very good. It is a XT graph. So XT graph is, what is that? Is a speed, or you can say velocity, because displacement na I should use velocity. So velocity is nothing but, I can write velocity is nothing but, it is nothing but slope, we know, right? It is nothing but slope. It's nothing but change in displacement by change in time, which is also written as, what is it here? Tan theta. Yes or no? Now theta concepts is important. Now you see this one and this one parallel. The two lines are parallel. Theta angle will be how much here? 0 degrees. Yes or no? Yes or no? Displacement also become parallel to whom here? Display time. Am I correct? Angle between them is how much here? 0. So if I put a 0 angle, what happens to velocity now? Tan 0. So tan 0 value will be, what is it here? 0. So velocity is becoming 0 means the body condition will be, when it will be 0? At rest. Body came to rest. Yes or no? So the particle came to rest. Okay. Yes or no, right? What it earlier it is increased like this non-uniformly, but at sudden one point now it become constant. Now what is happening here? I can go with the slope of the graph, which is xt graph. So slope, which is nothing but velocity, which is nothing but change in displacement by time. I'm sorry, and then tan theta. Theta is actually that 0 degrees. So and 0 is 0. So body is coming to rest. Learn the graph here only, because in upcoming days you will not be taught by the graphs. Okay, so many quantities will vary like that. How are you? Are you write down that? All okay? Super, super, looks good, looks good. I met him just now. Yes. What is going on? Where did you say? Wait. Akka? I will find it. Date? One five. 7, 20, 24. This month, one added. Yeah, change. Change should be. Yeah, that's it. We are doing too many classes, bro. Okay, so I have to check. Many students are there going to the next year. How is it? Where you joined in? BIT. BIT where? Vellore. You joined in Chennai. Why you would have joined Vellore? They told the Chennai. And even place would come to Vellore only, right? Same, because they will be available. Same group you have taken, right? So CS. I took information. Very good. Very good. You chemical engineer. What sorry? Okay, okay, that's it. All good. Meet me outside. Okay, whenever you're free, now you come. Okay, we can. I think VIT la, I think my students are there. My seniors might be there. They might be studied in a Velamma. Okay, chill. Be happy. I'll be available. Any need personal need, na, you can call me. Okay, okay, buddy. Take care. How can you leave alone? Parents, whatever. So, they can throw him out. No issue. Already thrown him out. You buddy? Fine. Chill. Anytime you need na, call me. I'll be there. Bye. 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 Guys, did you done? They are your seniors. Past or seniors. Very good guys. Chalo. Next, this question. But you finished? Huh? My time is wrong. I have to set it. Okay, guys, finished. Now, what is this indicates? Tell me. Can you just guess what is the answer for this one? Huh? By the slope, can we do it? Yes, of course we can do it. Listen. Now, let's say the figure 1. What is this, buddy? What it indicates? XT graph. This also XT graph. Now, what is happening after T time? T time, now you see this one is completely becoming like this, like this, like this. Yes or no? Yes or no? I'm going in perpendicular to what is it here? Time. Yes or no? So what is happens here? We know that slope of xt curve is velocity, which is nothing but change in displacement by change in time, which is also what is it here? Tan theta. Now helpful is tan theta only. Now tan theta, value will be what is it here? Perpendicular, which means how much here? 90 degrees. So V value will become positive tan 90 degrees. Tan 90 is how much here? Tan 90 is 1. Very good. Who is your math teacher? Best fellow. Huh? It becomes a infinity. Yes or no? Yes or no? Means it is keep on increasing or not? Keep on increasing, right? So rapid increment will be there. So I can clearly see body is accelerating. Our particle is accelerating. Accelerating. Yes or no? Acceleration will be there. Now what about this one now? Second body. Second body, you tell me now. Guess what? Now body is like this it is going. Now after that, what is it becoming? Parallel to time. Yes or no? Say then what happens if V is equal to tan theta? Theta value is how much now? 0 degrees. Theta value is how much then? 0. So if tan theta value is 0, then what happens now? Tan 0 is what is it here? 0. Yes or no? So now I cannot say 0 directly. How would I say? The particle is completely becoming, it is going to be positive. Yes or no? Here particle is what is it here? Trying to become 0. Yes or no? It become means it is coming to 0 only. So what is happening to the particle here? Retarding. What is this it is doing here? Retardation. What is this one here? Accelerating. Retarding after braking, what happens, buddy? You apply brakes continuously. What happens to that body here? It comes to rest. Finally, it will be rest. So, retarding and then comes to rest. Are you getting my point here? Here it is accelerating like anything. Yes or no? Here it is a retarding and comes to rest. Clear? Any difficulty? Yes or no? This is not a design, buddy. This is how you need to analyze the graph. Okay. So when you do like MTech, MBA, yes or no, there you have to analyze. Analytics will be there. So how to analyze? Like this. Here only you learn freely. Chalo. No sir, we are paying like that. You say, huh? Chalo. See that dude. He's simply sleeping. Playing with a galvanometer. Keep it away. I'll buy some toys. One car, one small bike. We're changing that. Kids. Yes or no, Ooty girl? In Ooty, is there any toys available? One teddy bear, Barbie, one small comb also. We need to buy for them. Idiots are there here. Shall we? Okay. Can I move on? Okay. Yes, buddy, are you writing still? Joshua, what's your name? Navya, are you writing? Completed. Chalo, write this question. Do this one. Buddy, can you just bring some water? Is it done? So now we try to analyze during the interval of OA, AB, BC, CD, the acceleration of the particle. What is it? We need to find a acceleration of particle, whether it is 0 or whether it is positive or whether it is negative or what is it? We will try to see. Is it okay? Shall we? Okay, let's do it. Now it is which graph is this one? Yes, means that displacement time graph only, no? Even y and t is also indicate what is it here? Displacement time graph only. Shall I? Now let's see this OA. If I try to draw a small lines here, you see this graph is going towards the time. Yes or no? So if I just analyze O to A, what is it here? If it is tries to like this is a time, this is what is it here? Well, displacement, and the graph is going which direction here? Towards the time. Yes or no? It is tilting towards the time. So tilt towards the time, na? The time. Then what is it here? Its velocity is decreasing. Yes or no? So what happens tilts towards the time na? What happens I can say velocity is actually what is it? I cannot say velocity but I can say acceleration. I am talking about acceleration now. So acceleration will be what is it here? Completely going towards a negative direction. So it will be what is it here? Negative. So you can imagine if the same graph is going towards what is it here? Time side it is coming. So I can simply say it is actually negative. Acceleration is becoming negative means retarding. What is this one here? Retarding. Retarding means what is that here? Retarding or applying brake, something like that. Negative it is coming. Then what about the velocity now? Velocity also what is it? It will become now? Tell me. Velocity also becomes what is it here? It tries to become a negative. It reduces or not? Reduces or not? Obviously it will reduce. If they ask velocity also you can answer. What about now? Next one more line I will try to see. A to B. Now this graph continuously shows that A to B condition, which is I am talking about A to B now. What is this ray? You see, it is actually becoming constant or not like that? Yes or no? If displacement is not changing, time is changing. So what is the velocity now? 0. What about acceleration now? 0. Similarly, now you can guess B to C what is happening here? B to C. It is see here it is going little bit up direction, rising, right? So the curve is going towards whom here? Towards the displacement. So acceleration will be what is it now? Positive. Yes or no? Now what is the next one here? C to D. C to D, the graph if I try to show, you can draw small dotted line. This graph is trying to go towards a displacement. Yes or no? So I can write same thing here. Tilt towards what is that, right? Towards y axis. So acceleration is what is that here? Positive. Got it? Write down. That's it. Is it done? Easy? Difficult? When you know it will be easy only. Put your scale down, buddy. Shall I move forward? What happened? Just fix it. Keep it down. Keep it down. Done, buddy. Shall I move on? Do this question now. Fast. So what is the answer? This is also which graph here? Displacement time graph, like this. Okay, we need to find the instantaneous velocity of the particle is negative at a which point? Which point? Tell me. C point, are you sure? Yes or no? Now A to B it is completely increasing like this. Am I correct? But when it comes to C point, it's going downside. And again, what is it? Again, it is increasing. Yes or no? So where is it? At C point, it is possible that the instantaneous velocity value will be negative. Yes or no? Okay. So that's all for today. Now read. You have one more class, right? So read now. If you got any doubt now, you ask. Switch on the light.